Dear students, this is the continuation of the previous video. Okay, now we see here the definition for harmonic. Okay, suppose the given function f of z is equal to u plus iv. When we say that the given function is harmonic, we have to find u and v. We have to find the real part and imaginary part from the given function. Then we have to check the Laplace equation for u and v. Suppose u and v satisfies Laplace equation, then we can say that the given function f of z is harmonic. Okay, so this is the Laplace equation. In another way, I write the Laplace equation here. You see here, the second derivative of u with respect to x partially plus the second derivative of u with respect to y partially is equal to 0. Okay, similarly for v, suppose u and v satisfy these two conditions, then we can say that the function, the given function f of z is harmonic. Okay, now we'll see few examples. Okay, now check the following functions are harmonic. Okay, we'll see whether it is harmonic or not harmonic. Okay, now see the first question, that is w is equal to f of z is equal to z square. Okay, now what is z? We know that x plus iy. So now write x plus iy for z, then you make square, that is x square minus y square plus i2 xy. Okay, now what is f of z? We know that u plus iv. Okay, so now what is u? U is nothing but x square minus y square. What is v? V is nothing but 2xy. Okay, now so we know that what is u, we know that what is v from the simplification. So now we have to check the Laplace equation, that is dou square. You see the second derivative, you see the second derivative of u with respect to x 2 times. Okay, plus second derivative of u with respect to y 2 times. Okay, that is equal to 0. Now you see, similarly we have to check for v also. See, for your understanding, I write here ux, partial derivative of u with respect to x, that is 2x. Okay, from this equation, u is equal to x square minus y square. What is ux? That is 2x. Then uxx, what is uxx? That is 2, because we are differentiating with respect to x partially, so that here 2 multiply x, x becomes 1, so 2. Now similarly you find uy is nothing but partial derivative of u with respect to y, that is here we have x square minus y square, this will become 0, so this is minus 2y, that's why I write minus 2y in uy. Now how to find uyy? From this we can find. Now again we differentiate partially with respect to y, that's why here partial derivative of y is 1, so here minus 2 times 1, that is minus 2, so that uxx plus uyy, that is nothing but 2 minus 2, that is equal to 0. Similarly you can do for v also. Okay, now u and v satisfies the Laplace equation, that's why we can say that u and v are harmonic, therefore we can say that the function is harmonic. This is the way how to check the condition for harmonic. Okay, now you see w is equal to f of z is equal to sin z. Already we know that, actually we have seen in the last video. Now w is equal to u plus iv, you put z equal to x plus iy, and then you apply the trigonometric rule, then you make simplification, you will find this one. Here what is u? U is this. What is v? V is this. So now you see ux comma y is this, vx comma y is this. Now what we are going to do, again we have to do the partial derivative of u 2 times with respect to x, partial derivative of u 2 times with respect to y, then you make the summation, definitely this is equal to 0. You have to do the partial derivative. Okay, similarly you do the partial derivative for v 2 times with respect to x and with respect to y partially, then you will get answer 0. Okay, so here u and v satisfies the Laplace equation, therefore u and v harmonic, that's why f of z equal to sin z is harmonic. Okay, now we'll see here steps to find harmonic conjugate. See, actually we are going to find v, this is harmonic conjugate of u. Okay, so now what is given in the question? U is given, then we have to check whether the given function u is harmonic, that is uxx plus uyy equal to 0 or not, we have to check. Okay, if it is harmonic, we can proceed further. Okay, then we have to use the CR equation, the first equation, ux is equal to by. From this you have to find, you have to take by, then integrate with respect to y, then we can find the function b in terms of x and y plus h of x. What is here h of x? This is nothing but the constant, because here we are doing the, see here, b y, which means the partial derivative of b with respect to y, so that we have to keep here x as a constant. Okay, that is here, keep x as a constant when you integrate with respect to y, when you find b. Okay, now then you have to find h of x. What is the value of h of x? By using the CR equation, another equation, because we have two CR equations. The first one here, second one is here. By using the second equation of CR, we can find the h of x. We can find the value of h of x. Then we can write b. What is b? Okay, actually these are the steps how to find the harmonic conjugate b if u is given. Okay, we are going to see by two examples. Okay, now verify that each given function u is harmonic, and then find a harmonic conjugate of u, construct an analytic function. Okay, now the first question is u of x comma y is equal to x cube minus 3xy squared minus 5y. This is the given function u. Okay, now we have to check first that function u is harmonic or not harmonic. You see, verify that each given function u is harmonic. Okay, now we will check what is the condition for harmonic. We have to check that u is satisfying the Laplace equation or not. Okay, now see here, make the partial derivative of u with respect to x, that is 3x square minus 3y square. Okay, how? One time I explain here. What is dou u by dou x? You go here, differentiate this partially with respect to x. Now here x cube we have, so we can differentiate with respect to x, so which means 3x squared we will get. Now here minus 3xy square. Now we are differentiating with respect to x, so that you keep y as a constant. Okay, so now minus 3y squared is constant. You have to differentiate only x, so that you will get here minus 3y squared. Okay, because the derivative of x is 1. Now here what is minus 5y? Here we are doing the derivative with respect to x partially, so that this is constant, y is constant, so minus 5y is constant, so derivative is 0. That's why here 0. Okay, so now dou u by dou x, here 3x squared minus 3y squared 0. We can leave 0. Okay, now similarly you can find dou squared u by dou x squared. Okay, from this one. Now dou u by dou y you find from this, then dou squared u by dou y squared you find from this one. Okay, so what you have to do now, you have to add, see, dou squared u by dou x squared with dou squared u by dou y squared. Okay, you add, that is 6x minus 6x. See, that is here, this is the Laplace equation for u. So you add 6x with 6x with minus 6x, so it will become 0. Therefore we can confirm that u is harmonic. Now we can proceed to find b. Okay, because we are going to find the harmonic conjugate of u. What is the harmonic conjugate of u? That is b. Okay, how to find? Now you see, we are going to use CR equations. We have two CR equations. Okay, first one is ux is equal to by. Ux means, see, dou u by dou x is equal to dou v by dou y. Okay, now you take this one. First is CR equation. Now we know that 3x squared minus 3y squared. Okay, actually if the given function is harmonic means, listen here carefully, CR equation satisfied, so that you see here I can find dou u by dou x, I can find, okay, from the given question, that is here 3x squared minus 3y squared. By CR equations I can say that this dou u by dou x is equal to this. Okay, I assume that, we can say I assume that. Okay, so now because if it is harmonic, CR equations are true, so that I write dou u by dou x is equal to dou v by dou y. So now all these are equal, therefore I can take the first part, means dou v by dou y is equal to this. you consider only this. See, that is here integrating the first one, which means you have to integrate this. Okay, now for the integration, see, I write here separately. See here, what is here vy? You see vy, what is vy? Vy, that is dou v by dou y is nothing but 3x square minus 3y square. See, I am writing here. Okay, so what we have to do, if you follow the steps from the previous slide, okay, here what we are going to do, you have to integrate with respect to y. Okay, so now if you integrate here, you will get v. Then here if you integrate, you will get, see, integration 3x squared dy minus here integration 3y squared dy. Now you integrate with respect to y. Suppose if you integrate with respect to y, what you will get, you see here 3x squared is constant. Okay, so now integration dy is y minus here you see integrate with respect to y, therefore here 3y squared, this will come 3y cube divided by 3, so 3 cancelled, so it will become minus y cube. Here why I am putting this h of x, because we know that after the integration we have to add one constant. Why I put h of x? Because here partial derivative we are doing integration with respect to y, therefore x is also a constant, so I put h of x. Okay, now how to find this? Because this is v, how to find h of x? Now you see here, we know that the second part of the CR equation, that is dou v by dou x is equal to minus dou u by dou y. Okay, so use this result now here. So now what is uy? We know that what is uy? 6xy plus 5. Okay, from here what is minus vx? See here, vx, from this we can find what is vx. Vx is nothing but 6xy. Okay, here minus 3y square h dash of x. Okay, so but here with respect to x I differentiate, so this will become 0, not minus 3y square, this will become 0. Okay, so that 6xy minus 0 plus h dash of x. Okay, this negative sign I'll put this side. See, I put arrow. From this I can write, see here, so uy, this minus I put this side, that's 5 minus 6xy minus 5 becomes 6xy plus 5. Then I write vx from this one. Okay, so that you can find h dash of x is equal to 5. Okay, then again integrate, you will find h of x is equal to 5x plus c. Okay, so here see, actually this I explained here, actual answer is this one, actual answer is this part. Okay, see here it is given directly to make you understand. I explained here. Okay, so that you can write what is b. What is b? B is nothing but, you see here, after this you see here v of x comma y is equal to 3x squared y minus y cube plus 5x plus c. Because from here we know that what is b, you have to replace h of x value from this one. Okay, so that's why you will get b. After finding b, we can write f of z equal to u plus iv. U is in the given equation plus iv is nothing but what you have calculated now. Okay, that's it. Now see this second question. U is e power minus 2x sin 2y. We know that how to prove harmonic. So now I am finding the Laplace equation whether it is true. Yes, it gives 0. Therefore u is harmonic, so we can find v. See, to find v I am using the CR equations condition. Now here you see here I am using second condition of CR equation. You can take anything, first one or second one. I am taking the second one, so that here you must understand we are going to integrate with respect to x. Okay, that's why here I am putting gy. This is the one difference from the previous question. Okay, so that next you can find vy and then you can find g dash of y. Okay, by using the first equation of CR. Okay, so that you can write what is b. What is b? That is e power minus 2x cos 2y plus c. See, in the previous question I explained we have taken vy and then we integrate with respect to y, so we kept x as a constant. Now very simple, now we have considered bx, so integrate with respect to x, so y is constant, that's why we are getting g of y, so that here we are finding g dash of y, then you can find again the value of g of y. Okay, now that is only constant because here derivative is 0. Okay, after finding u and b, you can write what is f of z, nothing but u plus iv. Now you substitute u and b, you can find the analytic function. This is our f of z. That's it. Thank you.